In this lesson, we're going to talk about factoring polynomials. So first, you should always look for your common factor. So on number 1, we have a common factor of x. So if we divide that out, x cubed divided by x is x squared. Negative 4x squared divided by x is negative 4x. And negative 5x divided by x is negative 5. And then I'm left with a trinomial. So I will factor that. I have one positive and one negative. And what multiplies to make 5 that subtracts to make 4 is 5 and 1, but I need that middle to be a negative 4, so 5 has to be negative and 1 has to be positive. On number 2, our greatest common factor is 3y to the third. So if I divide that out, 3y to the fifth divided by 3y to the third is y to the second. And negative 48, y to the third divided by 3y to the third is negative 16. Now when you have two terms, you're going to look to see if you have two perfect squares with a minus sign. We are going to talk about two perfect cubes today, but for right now, two perfect squares with a minus sign, I do have that, so that will factor into two binomials with a positive and a negative. The square root of y squared is y, that goes in the front, and the square root of 16 is 4, that goes in the back. On number 3, our greatest common factor is 5z to the second. So 5z to the fourth divided by 5z to the second is z to the second. 30z to the third divided by 5z squared is 6z. And 45z squared divided by 5z squared is 9. Now I'm left with a trinomial. I'll factor that into two binomials. Since there's a plus in the back, I look up front and I have two plus signs. And what multiplies to make 9 that adds to make 6 is 3 and 3. And since I have two of the same binomial, that means that was a perfect square trinomial, and we can write that as x plus 3 to the second power. All right, number 4, our greatest common factor is 5y to the fourth. So 5y to the sixth divided by 5y to the fourth is y to the second. And negative 125y to the fourth divided by 5y to the fourth is negative 25. And that gives me two perfect squares with a minus sign. So I have a difference of two squares that splits into two binomials. So I have y plus 5 and y minus 5. All right, so let's talk about the sum and difference of two cubes. So remember, like a perfect square would be like 4, because 2 times 2 is 4. I could write that as 2 to the second. So all of the exponents or the multiples that I have will divide by 2, because that's what we have out here when we root something. So an example of a perfect cube would be like 8, because that's 2 times 2 times 2, which would be 2 to the third. And that power will divide by that root of 3. So you're looking for multiples of 3. So when you look at the front, you need a perfect cube in the front, and you need a perfect cube in the back. So this is what you are given. This is what you will factor into. All right, so you want to write what you have as a perfect cube. Now these formulas are really similar. The only difference is when you have a sum, there's going to be a plus sign here in your binomial. There's always a plus sign in the back, and then there's always one minus sign. So if this is the plus up front here, and you always have a plus back here, that means that the minus has to go in the middle. If you have a difference, then this will be a minus sign in the front, and then the other two have to be your plus signs. So first you want to write what you have as a perfect cube. So this is already written with an exponent that divides by 3. All right, 125 is the same thing as 5 to the third. So 5 times 5 times 5 is 5 to the third. If you're unsure what it is as a cube, you can go to your calculator, press the math button, and go to where the cube root is and cube root your number. So I could cube root 125. It tells me that it's 5. So I know that that's 5 to the third. That's if you're using a TI 84 plus series calculator. All right, so I know that in the front, a is represented by the number that is being cubed. So what's being cubed is the x value. And then the number in the back that's being cubed is 5. So a is x and b is 5. And I am just going to plug into the difference formula. So I have my a minus my b. Then I have to square my a, multiply a and b, and square my b. So I have a binomial in the front, and I know that between my two perfect cubes, that's the sign that will be in the binomial. A goes in front, b goes at the back, and then I have a trinomial. So I square the a value, so that would be x squared. Since I already have my 1 minus, the other two signs in my trinomial will be pluses. Then in the middle, I multiply the a and the b, so I get 5 times x is 5x. And then at the back, I square my b. So 5 squared is 25. All right. Now, I did not have a common factor on 5, but I do have a common factor on 6. So my greatest common factor is 2s squared. If you have a common factor, you should always take that out to begin with, right in the very beginning. So 16s to the 5th divided by 2s squared would be 8s to the 3rd. 54s squared divided by 2s squared is 27. And then what I'm left with is perfect cube, perfect cube, perfect cube. So if I write 8 as a perfect cube, that would be 2 to the 3rd power. And then I have s to the 3rd power. And then 27 is 3 to the 3rd power. Now I can write this first one, instead of doing two different things to the 3rd power, I can combine them as 2s to the 3rd. That way I just have one thing raised to the 3rd. So that means my a value is 2s and my b value is 3. Now I do have that common factor that needs to go out front, and then I can put my binomial and my trinomial. So I know that the sign of this binomial is positive because that's what's in between my two perfect cubes. And then a goes in front, b goes at the back. And then we have our trinomial, so I'm going to square 2s. Now, if you square 2s, you have to square the 2, and you have to square the s. So 2 squared is 4, and s squared is s squared. All right, since this is a plus up front, I know that my minus has to be in the middle. And then I'm going to multiply the a and the b. 2s times 3 is 6s. There's always a plus at the back. And then square your b. 3 squared is 9. No common factor on 7, so I'm going to go ahead and write these as perfect cubes. 64 written as a perfect cube is 4 cubed. So my a value will be x, my b value will be 4. So if I plug into the formula, I know that the minus is going to be up front in my binomial. A is x, b is 4. Square your a, so that would be x squared. Since I already have my 1 minus, this is a positive. X times 4 is 4x, and then this is always a plus at the back, and then square your b, that gives you 16. All right, I do have a greatest common factor on 8, and since my first term is negative, I'm going to factor out a negative with my common factor of 2x squared. So negative 16x to the 5th divided by negative 2x squared is 8x to the 3rd. And negative 250x squared divided by negative 2x squared is positive 125. And then I'm going to write my 8 as a perfect square, or as a perfect cube. So I have 2 to the 3rd, so this will be 2x to the 3rd plus, and then 125 is 5 to the 3rd. So I know that my a value is 2x, and my b value is 5. So I'm going to put my common factor in front. I have my a is 2x. The sign, be careful because you did factor out a negative, which means it's not going to be a minus. It's going to be what's in between my two cubes now, which is a plus. So plus, and then my b. Then I'm going to square my a. 2x squared would be 4x squared. Multiply 2x and 5, that gives you 10x. And then square your 5, that gives you 25. but generally you can do the first two and the last two. You just need to find two that have something in common. So I know that these two have an x squared in common and these two have 4 in common. So I'm going to group together the x cubed plus 5x squared. And then I always put a plus in between, and then I have the negative 4x minus 20. All right, just make sure that if that third term has a minus that you pull that in to your parenthesis. All right, then you're going to factor out a common factor. Well, I see that in my first one here, they have an x squared in common. So I'm going to factor out an x squared. So x cubed divided by x squared is x, and 5x squared divided by x squared is 5. All right, then I see that I have a negative 4x in front there. I don't like the negative, so I'm going to factor out a negative 4. If I was factoring out a positive number, I would just put a plus instead of the minus. That leaves me with x plus 5. Now, your goal is to get the same thing left over after you take out those common factors. So you're going to think of this as one whole term and another whole term. What do those terms have in common? Well, they both have an x plus 5. So if I factor out that binomial, I am left with x squared when I divide it out of the first one, and I'm left with negative 4 when I divide it out of the second one. It would be the same thing if I said that I had 2x squared a plus 4a. Both of these have an a, so I would take the a out, and I would be left with 2x squared plus 4. So it's the same thing. It's just a little bit different because it has that binomial. Then you're going to look to see if you can factor what's left over. I do have difference of 2 squares here, so I will leave this linear factor alone, but I need to factor this. Positive and negative. Square root of x squared is x, and square root of 4 is 2, and I can't factor that any further. So if you take a look at number 10, again, you do not have any common factors. So we're going to go ahead and group together the first two because they do have a common factor, and put a plus, and then group factor. So the common factor in my first grouping is x squared, so I factor that out. That leaves me with x minus 2. And then the back, I don't like that that first term is negative, so I'm going to factor out negative 9. If I divide that out, I get x minus 2. And again, I'm looking for what's left here when I factor out to be the same. So if I factor out the x minus 2 from the first group, I'm left with x squared. And if I factor it out from the second group, I'm left with minus 9. And then I can see I have a perfect square in the front and the back. So I have a difference of 2 squares on this second binomial. So that leaves me with x plus 3 and x minus 3. All right, number 11 also does not have a common factor, and I do see that my first two have a common factor and my second two have a common factor as well. So I'm going to go ahead and group those together. My common factor in the first group is y squared, so I'm going to divide that out of both. 3y squared divided by y squared is 3y, and y squared divided by y squared is 1. This is a common mistake, is to leave this number as like 0, and so you just have 3y left here. But remember, if you're factoring out, if you start with 2 terms, you should have 2 terms in your binomial after you factor. And then the common factor back here would be a positive 3, put that plus there. So 9y divided by 3 is 3y, and 3 divided by 3 is 1. And again, we got that 3y plus 1 that is the same in both groups. So 3y plus 1 is what I'm going to factor out of each group. And I'm left with y squared plus 3. And neither of these can be factored further, so that is my final answer. Number 12, still no common factor. Remember, if you have a common factor, you need to take that out in the beginning. My first two do have a common factor, and my back two also have a common factor, so I will group those together. My common factor in the first group is x squared, so I'm going to factor out x squared, which leaves me with x plus 4. Now that's really similar to what I have in this back here. It's just the signs are wrong. So again, you can take out a -1, which leaves you with x plus 4. So in my two groupings, they both have an x plus 4. So if I divide that out of the first group, I'm left with x squared. And the second group, I'm left with -1. And then I do have that difference of two squares. Remember, 1 is a perfect everything. So that gives me plus and minus. The square root of x squared is x, and the square root of 1 is 1, and I can't factor any further from there. All right, so obviously number 13 is not factoring by grouping, but I do have two terms. So I'm going to look at those two terms and decide what I should do here. So I either have perfect squares or perfect cubes. That's the only way I'm going to be able to factor that. And I see I don't have any common factors, and they're definitely not perfect cubes because 4 does not divide by 3. So I do have two perfect squares and a minus sign, so I will factor that into 2. Plus and a minus. The square root of 16x to the fourth is 4x to the second. And the square root of 81 is 9. And then I cannot factor the first binomial because there's a plus sign in between my two perfect squares, but I can factor the second because I do have a difference of two squares. That gives me plus and minus. The square root of 4x squared is 2x, and the square root of 9 is 3. All right, number 14, we do have a common factor of 3p squared, so we're going to factor that out first. That leaves me with p to the 6th plus 5p to the 3rd plus 6. And I have a trinomial here. Now remember, as long as, if this is p to the 6th, as long as this is half of that, and then you don't have another p, then you can factor that just like you would any normal, x squared with an x kind of trinomial. So we have two plus signs. To get p to the 6th, I need p to the 3rd times p to the 3rd. All right, it's always going to be whatever is right here. And then what multiplies to make 6 that adds to make 5 is 3 and 2. And then both of these cannot be factored any further, so that's my final answer. All right, number 15, I don't like that I have that negative in front, so I definitely want to take that out. I don't have a common factor, but I do see that I have two perfect squares. So first, let's take out that negative. That leaves me with 16n to the 4th minus 625. So now that I've taken out that negative, I do have a difference of two perfect squares. So I will factor both of those. Or I'll factor this one. So I have a plus and a minus. The square root of 16n to the 4th is 4n squared. And the square root of 625 is 25. So again, I do have two perfect squares, but I can only factor the one with the negative in the middle. So I'll leave the 4n squared plus 25 alone. And I will factor the 4n squared minus 25. So I have plus and a minus. The square root of 4n squared is 2n, and the square root of 25 is 5. All right, number 16, I do have a common factor of 5w squared. So if I factor that out and divide it out of all the terms, I'm left with w to the 4th minus 5w squared plus 6. And remember, as long as this is w to the 4th and this is half, you can do that with, no w there at the end. So I keep my 5w squared out front, and I will factor back here. I have two minus signs. I need w to the 4th, so that would be w squared, and what multiplies to make 6 that adds to make 5 is 3 and 2, and those cannot be factored any further. So now we're just going to solve. So we'll do everything that we've been doing, but when we get our factors, then we're going to set those equal to 0 and solve the equation. So if you have a common factor, make sure you take that out in the beginning. I do have a common factor of 2x. So if I divide that from all three terms, I'm left with x squared minus 6x plus 9 equals 0. And then I'm going to factor this trinomial. So I have two minus signs. And what multiplies to make 9 that adds to make 6 is 3 and 3. So notice that you do have three answers. So when you get done, you should have three answers in your answer set. And I have 3 factors here, but I do have a repeating one. So I have 2 of the x minus 3s. So I know that I have a multiplicity when it comes to that factor. So I'm going to set my factors equal to 0. Since you have 2 of the x minus 3, you only have to do that once. So I'm going to solve by dividing by 2. So I get 0, add 3, and I get 3. So my solution set would be 0, and then 3, which has a multiplicity of 2 because there are 2 of them. So if you would have had 3 of the same factor, you would say multiplicity of 3. So on 18, we have a common factor of 5x. If I divide that from all 3 terms, I'm left with x squared minus 8x plus 16. And then I'm going to factor what is left in this trinomial. So I have 2 minus signs, and what multiplies to make 16 that adds to make 8 is 4 and 4. So again, I know that I have 3 answers, and I do have a multiplicity on that factor of x minus 4. So we'll set the factors equal to 0 and solve. So when I divide by 5, x equals 0. I'll add 4, x equals 4. So my solution set is 0 and then 4, and I'm going to abbreviate here, which has a multiplicity of 2, and then you have your 3 answers. When it says find the zeros, it's the same exact thing, but instead of having it set equal to 0, it's just showing your function. So you will set it equal to 0 yourself and solve. I do have a common factor of -2, so I'm going to factor that out. That leaves me with x to the 4th minus 8x squared plus 16 equals 0. Now you can divide by that -2 since it doesn't have a variable with it, or you can just leave it because it's not going to have any bearing on what your zeros are. We're going to go ahead and factor. We have 2 minus signs. Since it's x to the 4th, we'll do x squared. And what multiplies to make 16 that adds to make 8 is 4 and 4. Now I do have a multiplicity with the x squared minus 4, but they are both the difference of 2 squares. So we're going to go ahead and factor the difference of 2 squares. So I have a plus and a minus. The square root of x squared is x, and the square root of the 4 is 2. And then I have another difference of 2 squares that's exactly the same. So I have another x plus 2 and another x minus 2. So I have 4 answers on this. If you look, you will not set this -2 equal to 0. You can't make -2 equal 0. So if you have a factor out there that's just a constant, it doesn't have a variable, you don't set that one equal to 0. So I have 2 of the x plus 2's, and I have 2 of the x minus 2's. So I will set one of them equal to 0 for each set. And that gives me -2 and +2, and both of those have a multiplicity of 2. So I have -2 with a multiplicity of 2 and +2 also with a multiplicity of 2. All right, on 20, I do not have a common factor. I'm immediately going to just factor this into 2 binomials. I have 2 minus signs. X to the 4th would give me x squared, and what multiplies to make 81 and adds to make 18 is 9. And then again, I'm with the same situation here. I have the same binomial factor and their difference of 2 squares. So I will factor that, plus and a minus. The square root of x squared is x, and the square root of 9 is 3. And then I have another set just like that. So another x plus 3 and another x minus 3. So I will set x plus 3 equal to 0 and x minus 3 equal to 0, remembering that I do have 2 of each of those. So I will have 2 separate multiplicities. So I end up with x equals -3 and +3. So I have -3 with a multiplicity of 2. And then +3 also with a multiplicity of 2.